I'm Lance. Hi. You can see my contact details things there. GitHub stuff there. What am I going to talk to you about? Well, I'm going to tell you briefly about me. I'm going to tell you about a project I worked on at the Home Office, not Barclays, called DRT. I'm going to tell you some problems that we had with that when I first started looking at it. Some solutions we looked at. It's going to be Scala and Scalajs. Surprised. A little bit of akka-persistence as well. I'm going to tell you about the good bits we found, the bad bits we found. Might have time for some questions, but we certainly will over where there are drinks. A little bit about me. I'm from a tiny town in the middle of North Island, New Zealand, called Tirau. There's a population of about 700 people. The idea growing up that I would one day live in London is kind of weird. It's mostly famous for this giant corrugated iron sheep. Yeah. These weren't here when I lived there. They came along when I was about 16. From about age 5, as is the way with all Kiwis, we had pet sheep. That is indeed me, age 5, with my pet sheep. Yeah, his name was Cheeky. When I wasn't playing with my sheep and teaching it how to follow and stay, then I was on my Amstrad CPC 6128 quality English machine by Alan Sugar. So I worked with that for a long time. Realized fairly early on that the games were far less interesting to me than coding, and thankfully the manual for the Amstrad was about yay thick, so I kind of became obsessed and read through that and various kinds of coding. Went to university, comp-sci degree at Waikato, found for the WECA big data, machine learning library. Worked in Auckland for a while and wrote database engines, which is not something many people do, I guess, but that's what we did. I moved to London in 2005 and spent about 10 years working for hedge funds, high-frequency trading, banks and media, working with big data before it was called big data, like many distributed things, lots of in-house stuff, that's not what to talk about. Immutable data stores and persistence and event sourcing, I think before Greg Young had named it. I'm a little bit obsessed with Kanban and I love automated tests, and that's sad. The story is about the Home Office. I worked there about a year ago and kind of helicoptered into various projects. Sorry, not that Home Office, this Home Office, the UK Home Office. Kind of helicoptered in onto various projects and helped them succeed a bit more than they were before, I'd say. The particular one I'm going to talk to you about today I was quite hands-on with. It's DRT, or Dr. T, depending who you asked, which stood for Dynamic Response Tool. Now, that was a tool used by the UK Borderforce at all of the major ports. We call them airports. So we're talking about London Heathrow, Gatwick, Stansted, Manchester, EMI, EDI, Glasgow. So what we're dealing with in this case is trying to predict queue lengths. In 2012, there was a little thing that happened in London, you might remember at the Olympics, and there were some very long queues, and people were a bit upset about the time to get in. That led to the institution of some SLAs. Now, the SLAs for that are how long is it going to take before you get through the e-gates or the desks and things like that. And if you don't get processed in enough time, then there's a ministerial breach and someone has to go and say, hello, Mr. Minister, or Mrs. Minister, sorry very much for us not processing people quickly. There's things like you have to be through e-gates in 15 minutes, plus up to 30 minutes leeway, and desks are 25 minutes, EU's 35 minutes, and anyone else, yeah, whatever, we don't care. 45 minutes. Now, before DRT, all of the predictions of how many staff and desks they had to have open were essentially based on guess variance. Just come up with this word, I don't know if I love it. What do you think? Yeah. It's guesstimation. So there was, when I'd go out to port visits to talk to the users, they're like, yeah, I've done this job for 30 years, I know how busy it's going to be when I come see the people coming down the ramp. And what we were trying to do with DRT is let them know 4 hours before the people are coming down the ramp. At a port like Heathrow, where there's 100,000 people coming in every day, a 5-minute delay in a flight can suddenly absolutely blow their SLAs, and if they don't open up some more desks. Now, DRT, when I first started with it, was my first attempt trying to draw on this slide package. It was kind of designed like this. Design is a term I use loosely. There was a little piece of Scala over here in a project called FlightStats. It was Scala-ish. It was responsible for talking to all of the airport's various feeds for flights we've got coming in, how many people are on them, things like that. Little thing we'll ignore called desk stats, and some great dreams for the future in a thing that is irrelevant now. That had the job of sticking messages onto a RabbitMQ, and then we enter PHP land. I know, it's a Scala talk. I'm about to tell you a little bit about PHP. Bear with me. So we had this little loader thing there that was picking up PHP. That was PHP trying to pick stuff up. It was putting things into a MySQL database. Then, where the interesting-ish bits happen, and it's not what this talk about is about, is the crunch. So that's taking all of the data, trying to then predict how many queues have to be open, also written in PHP, but it was translated from an R, this is the statistical modeling language algorithm that are being written by Home Office Science. That then stuffs its answers back into the database, and essentially it just becomes a very imaginable and standard dashboard. No screenshots, I'm afraid, but you can picture a table of times and numbers and red flashing warnings and things. Now there are a few problems with, oh, I've gone the wrong way. There are a few problems with what we had up there. Have I gone the wrong way again? There are a few problems with me, is the one. There we go, got it. Yay! A few problems with scheduling was one of the things. So everything was batch-based. The Scala little job was just polling the airports on sort of 15-minute basis, picking stuff up, sticking it onto a queue, but not too fast because PHP couldn't actually keep up, so there were all these crazy limitations in there. This would take 15 minutes to do its job. That would put the stuff in the queue. The crunch that was written in PHP would take 15 minutes for Heathrow. And so everything was always half an hour later, and as I said, kind of 5 minutes matters. It wasn't quite what I'd call fit for purpose. That aside, the little piece of flight stats in the top left-hand corner, that was, as I said, Scala-ish. It was largely Java, lots of vars everywhere, written in JBoss. The process tended to stay up, but the processing tended to fall over all the time. It was just a constant resetting thing. Remarkably, small bits of it were covered with tests, but the functionality as a whole just wasn't. We actually ended up naming it, and I've gone the wrong way again. We actually ended up naming it the unstable Squid, just because of the intertwining of the way all of the ports worked. There are a few other issues with what the way it was designed, which was, although that was a distributed system in the looser sense, every little box on that initial diagram was a separate process. Everything was coupled. There was not one part of it that could change without affecting effectively every subsequent part. And this was reflected in extremely long lead times for delivering a new feature. There was a request for, oh, this one port wants to rename a column that occurs, and we would have had to have changed almost everything that had been sitting on the backlog for 10 months, not necessarily because lots of other things were there, just it's slow. And the subsequent features that were about to come up didn't look promising in getting them delivered in a good time. The other fascinating part, about 60% of that PHP code was actually dealing with configuration. So there were pages in there so that you could say, well, when I'm dealing with an EU passenger from Macedonia, it'll take 30 seconds to deal with someone on average, but if I'm dealing with them from Italy, they're going to take 25 seconds. In Germany, they come through in 5 seconds because they've got really good passports. Actually a difference, seriously. So there was huge amounts of code, but no one actually used those. It was so slow and clunky to use and didn't quite match the things that what happened was Excel spreadsheets got filled out, given to the Scala, to the PHP devs, and once a week or every few weeks they'd do some uploading. And then the final thing was that, as with so many projects, suddenly there was a headcount cut and lost a couple of devs. I was like, gosh, what are we going to do? So we had the problems that it was slow to add new features. When we wanted to add new features, the whole premise of DOT was that it's about all the ports trying to look about the same. But they don't. Edinburgh wanted special behaviour so that when a piece of baggage comes in on this third carousel, that means that we were going to have to open another 6 terminals and another six desks, and that just wasn't going to fly in the system that we had. So we did try initially to fix it. We worked a bit on the crunch bit in PHP, and we managed to speed it up from a 15-minute processing time to a 6-minute processing time, which is okay, but still not adequate. We also had a whole bunch of team improvements. This is a talk for another time. We reduced the width, we started pairing, and we saw the most obvious uptick in cumulative flow reduction in lead time that I've ever seen. It's amazing. Talk to me about that later. So what did I do? Well, I spiked. And I spiked to look at solving 2 things. One was the slow crunch times. So this is where I talk about the back end. I spiked using Rengen, or R-engine. I'm still not sure how you say that. And that is an R engine for the JVM. So it's an implementation of R, runs on the JVM. And that was great. We were able to, it was easy to set up. Let's use akka-streams and akka-persistence to store all of our state and keeps up to date. Now, Rengen was very easy to set up, and the algo was 500 to 1,000 times faster. So there's 15-minute crunch times. We were coming through in under 5 seconds, usually, largely because R actually knows how to use the cores on a machine. So that helped. Now, the next part we used was to do all of that polling things. We used akka-streams. It was kind of cool. Question, this might be feedback for Alex. It wasn't really clear who the documentation was targeting. I don't know if anyone else has used this, but it was very difficult to find out the entry point. Some very simple concepts just were kind of glossed over, and I've got quite a lot of experience in rank persistence. It was like, okay, well, how do I do this? I'm saying it's kind of missing some cookbookish things. So Alex mentioned big long chapters of stuff where then you just miss it. We did end up spiking something solution end-to-end that was just in pure streams, and that was really very pretty, but we didn't use it because time. Now, akka-persistence was wonderful. I'm here to extol the virtues and not tell you anything more about it than that. Little warning if you do, and maybe it's being fixed in type. Well, it's wonderful because you get point-in-time views, PIT. So you can say, hey, what did my view look like at that particular time frame last Wednesday? But just kind of out of the box. It's really lovely. We struck an exploding mailbox issue after a few weeks live in Heathrow. And that was because I had decided to defer the decision to snapshot. Snapshotting is supposed to be, well, in every other system I've used, it was a performance optimization. So I don't have to read the whole stream to get up to state. I'm just like, what do I need to know to move from this point? Sort of a keyframe, if you know video stuff. And the problem was we didn't do that at first because performance optimization, and then one day when Heathrow got restarted, it just didn't come up. It was blowing up in memory. So as wonderful as akka-persistence is at managing the length of queues for your actors, it isn't so good when it starts up. It just slurped everything out of the database, gave it to the actor, and then boom, bye-bye memory. Word twice. Choose your serialization wisely. So as part of the headcount cuts, I was left with 2 primarily PHP devs. They'd never used Scala before. But in this process, I brought them along with me. And sorry guys, I've lowered your rates because there are now 2 new Scala devs out there. But doing quite well. They're now managing this project. Unfortunately, as they were new to the serialization on the JVM, they chose JVM serialization, which was a problem as soon as we wanted to start changing those messages. But it was easy to just fix that, and we used Avro in the end. Akka-persistence, as you've just seen, is a moving target, but the docs were great. Just lovely, really good. Scalajs with React. So now we're going on to the client side. One of the other things I wanted to solve was with that shrunken team, I didn't want to have to jump between 2 languages. It was enough of a load just to bring these 2 guys up to using Scala. So I experimented with Scalajs and Scalajs React. I hadn't actually used React before this, I don't think, apart from playing around with Redux. If you haven't seen that, watch the talk by someone Abramovich is wonderful. He essentially is taking lots of lovely functional mutable principles and applying it to the UI. It's great. Now you might be able to see from that number 0.11.1, that was what we were using. It's now at 1.2. It's been completely rewritten, and yet it's still wonderfully compatible. It was a doddle to transition up to version 1. It's a whole bunch of bindings for going into JavaScript. We had a few teething problems with it. When we first started with the SBT build, it used a concept called webjars, which, is anyone familiar with webjars? 1, 2, 3, like 4 people. So it's kind of, you take an NPM package, wrap it up and zip it in a jar, throw away all of the dependency information, and hope. Thankfully, it's a thing of the past now because some genius has written an SBT plugin that just lets you use Webpack and Yarn, and it's great. It just works. The build time's dropped absolutely off a cliff, and they're wonderful. Scalajs, like I say, mostly just worked. I only just started following the chap who wrote it on Twitter the other day because he saw us doing this talk and was like, oh my god, the fact that I didn't ever have to reach out to you or even know your name is a great testament to the wonderful work that he's done. Don't remember his name, I'm sure someone can tell you. Scalajs. So the testing scenarios are a little bit interesting. Scalajs has a couple of limitations. One that is specific and relevant to this is you can't use reflection. And Scala test and specs 2 both use reflection in order to find tests. Thankfully, a very productive chap, Li Hao Yi, has written a library called MuTest, and it's pretty good. It's very small, you just declare little functions, it's like early, it's not trying to be clever. The failure assertions are a little bit weird because there's a little bit of macro magic and you have to be careful what you're comparing when, or else you'll get slightly strange messages. Remember this when you try it. Also by Li Hao Yi, I told you it was productive, Autowire. So this is what I used for the protocol between client and server. Why not REST? Well, because we didn't know exactly where functionality was going to live, and one of the benefits of having the same language front and back was I could just use the same function in both places, move stuff around. Autowire gave us essentially RPCs, and it ties in very nicely with another thing I'm about to tell you about called Diode. One little gotcha with Autowire is you will be stung by a mutable seek if you have a habit, as I learned early on, to try and use it. So Diode. Now, Diode is a lot like Redux, if you've heard of that. It's about centralizing all of your state in your UI app into one place, keeping the flow of data in a single direction. Your views read from the model. They can create actions. The actions feed to the circuit, and the circuit can run effects, which might create more actions. So this is just this is a lovely thing to follow through, which is quite easy to understand. I'm bringing up code, but we don't have time to read it, so don't worry about that. This is the basic model of doing handling here. A model update is directly fudging with my model, but that's because we haven't bothered to use the niftiness that is the action handler, which uses a zoom to lens into your model, so that when you do an updated, you're effectively emitting a return saying, I'm going to change this value, and then the lensing just updates the model in the right place for you. Really quite lovely. Then the views. This is about as much Scalajs and React as you're about to see. So there you've just got like, here's a div, here's an H3, that's what goes in it. Here's a P, here's some buttons. This is the Onclick handler, that's just a lambda. That emits the event that gets handled, and that's the label that goes on the button. At the top, you just pull in the thing you want to render, and boom, God's your uncle, that pops up on your screen after a very long amount of compile time. Okay, so what did we have left at the end? Well, the original thing was, my favorite sort of pattern is the over and over again, which was as crazy. I've got lots of complexity. I'm going to make everything look the same. But the things that it varied by were kind of the things that came in the first place. And that's just a bit weird and confusing. By the end of it, I kind of lied to you. We didn't really go back to a monolith. We actually went back to an instance per port. So he throws there All of these share a lot of code. They're all in the same repo. They all actually have the same compile output. There's just a few bits of configuration, and most of that configuration comes through from code. All of that stuff that was there to manage all the times in the database, gone. It's just code, which means it's managed by GitHub. Now, what did we use? Architectural decision records, didn't talk about that, but check them out, they're amazing. Scalajs, React, Diode, Autowire, our project, thanks to the GDS policies, the code is open source. Read it and please don't judge, because it was my first Scalajs project and just walked off a tutorial. But that's me, and I'm 1 minute 54 seconds over time. So if you've got questions, I suggest we do it over wine or beer.